Hey there, class. Mr. Pusky here. Hope you're having a good day so far. We're continuing with, this should be the last section of 9.7, which is about dilations. Dilations can be classified as either enlargements or reductions. Basically, it's like taking a figure and like blowing up every dimension of it and kind of making it a bigger or smaller face. Bigger or smaller, not face, what am I saying? A bigger or smaller version of that shape, right? So you can take this triangle here in the warm up and you can make it like bigger like that, okay? Okay, we have warm up here. So this is how many lines of reflections does this figure have? Why don't you guys go ahead and give that a try? All right, so there should be, remember lines of reflection, should split it right on the, or split it so that there's a mirror image on either side. So there's 1, 2, oops, that was not a good drawing, 3. So there should be 3 lines of reflection for this. All right, awesome. So we can use, kind of like we talked about where we like translated using matrices, we can use what's called scalar multiplication. It's the process of multiplying each element, each what? Element, which is actually a what? It's actually going to be a number, right? Of a matrix by a real number or scalar, okay? The center of dilation is basically the point of intersection of the lines that you connect. So basically it's like you're kind of like, you're taking a point, external point, and you're kind of like, taking the distance between that point and point on the line, and like that's how you kind of make it bigger or smaller. You'll kind of see what I mean in a second, a little bit later, okay? All right, so identify dilations. So we need to find what's called the scale factor, which is K. And what we do is we divide, let's see here. We divide image, oops. Let's see here. So that's kind of weird how they wrote it here, but basically K equals image over pre-image. 1 second. Yeah, we're gonna do image over pre-image, okay? Okay, so basically where we ended up or over where we started, okay? And that's gonna determine like what kind of, if we have an enlargement or a, I guess a dilation, enlargement or a reduction, okay? So dilation is like the term of like making it bigger or smaller. Reduction is making it smaller, okay? And enlargement means making it bigger, okay? So if we like figure out that scale factor and K is greater than 1, it's going to be an enlargement. And if K is less than 1, it's going to be a reduction, okay? So let's do one example here and see how we do, okay? So we have this value, this drawing right here. We have these triangles. So basically C is kind of the what they call it, the center of dilation, right? So basically the original figure is this right here, and the dilated figure is going to be the new shape, right? Which is going to be this one down here, okay? So let's go ahead and talk about this. And what we can do is we can figure out like how much we scaled it by, whether it's an enlargement or a reduction, by taking the original distance from C to the image to the new distance from C to the image, the pre-image and then image, okay? So let's do this here. So we have K, it's going to equal, so we have the original, the image, which is CP prime, right? Because P prime is where we ended up, right? Over CP, which is the original thing here. So what's CP prime going to be? Well, the distance from C to P prime, where like after you do the dilation, is going to be 10. And the image, pre-image, sorry, is where we started, which is going to be 6. So if we do 10 divided by 6, that equals, K equals 5/3. All right. Is 5/3 bigger than 1 or less than 1? Well, if we divide 5 by 3, we get 1.67 approximately, which is greater than 1. So is this going to be an enlargement or a reduction? It's going to be an enlargement, okay, because K is greater than 1, okay? All right, so yeah, basically divide where it ends up over where it started, and then figure out if K is bigger than 1 or less than 1. Why don't you guys try the second one here? Hopefully I explained that well, but if I didn't, we'll do another example. All right, for B, so we need K equals the image, which is CP prime, okay? So actually we started, this shape is where we started. Oops. We started here, and we ended up, now this triangle is where we ended up, okay? So what's CP prime going to be? Where we ended up, that was 11. Oops. So we have CP prime over CP. So CP prime was 11. We ended up at 11, the distance. And CP was actually 22. Well, what's 11 divided by 22? K equals 1/2, right? Which is about 0.5, okay? So yeah, basically like a dilation is where you take the original distance from C to the distance, and then if you make it go closer to C, that's going to be a reduction, and if you go further from C, it's going to make it a enlargement. And if you do that with like every point on the shape, it'll actually like just make it bigger, which is kind of cool, right? If you did it over here, it would make that part bigger, okay? All right, so this is actually going to be, this is a reduction. 0.5 is less than 1, which is a reduction. And the K value is 1/2, okay? All right, sounds good. Okay, let's move on here. So it says keep in mind that C in the pictures is called the center of dilation. And what we need to do is we need to connect corresponding vertices and see where the segments cross, okay? So we have these shapes here. So what I like to do is just draw straight lines from, I guess like from matching point to matching point. So we have A and A prime. So I can't really draw a straight line here, but we'll do our best we can. So I'm gonna go like this. Just draw a straight line all the way across, okay? And same thing for B to B prime. Not perfect, but this is going to be where they cross, where these like basically connecting the pre-image and image points, and where they cross is that's going to be the center of dilation C. Okay. All right. Why don't you guys try checkpoint 1, see how you do. All right. So they give us a dilation where CP prime is 4. So CP prime is 4. So we do image over pre-image. So we have 4 over 20. What's that reduced to? That's going to be 1/5, which equals 0.2. So K equals 1/5, which is our scale factor. Is this going to be an enlargement or reduction? Well, 0.2 is less than 1, so that equals a reduction. Which that doesn't equal, I don't want to get rid of the equal, actually. So it's going to be a reduction. Awesome. Okay, now, let's go ahead and do this here. So, for example 2, now we're actually going to be like creating a dilation ourselves, okay? So it's going to be kind of tough on this software that I'm using, but I'll do the best I can here, okay? So we want to use a scale factor of 1/2, okay? So basically we're going to use the center P right here, and we're going to just connect P to all the points of this line segment AB, okay? So I'm going to draw a line straight across best I can. Let's try that again. Hopefully I can do better. Not great, but it'll get the job done. Okay, just kind of extend past there. And same thing for PB. Let me try that. All right, it's a little tedious. That's okay. So my drawing's not going to be perfect, but we'll do the best we can here, okay? So what we're going to do, like what you would do on your paper, if you had a paper version of this, is you would take, basically you would measure the distance from like P to A. So PA, if you measured that on your paper, it was about 4.7 centimeters. I might use centimeters because it's a little bit easier to work with. And we want to multiply that by 1/2. So that's the scale factor, K equals 1/2, right? So PA prime equals 1/2 times 4.7, okay? Which is approximately 2.4 centimeters. So on this line, the PA line up here, right? You're going to measure between P and A, you're going to go on that line 2.4 centimeters starting at P. And if you do that, you can see this is it's going to be somewhere in there. Let me do this. Right about right here, maybe. Yeah, it's kind of tough, but we'll do it like about right there, okay? Yeah, so this would actually be A prime, okay? If you basically, you take the scale factor, you multiply by the distance from P to A, and you go that distance from P, and that'll actually like plot the new point, and it actually will scale the image, and you'll see why in a second. Let's talk about PB. Well, why don't you guys go ahead and measure PB really quick? What do you get? Yeah, for PB, I got about 7.5 centimeters. We do the same thing. Okay. So we are scaling it using the scale factor, and you'll see why in a second. So PB, if you do 1/2 of 7.5, you're going to get approximately 3.8 centimeters. Okay. So then, yeah, so then if we go 3.8 centimeters starting from P towards B, it's going to be hard to visualize here, but we'll kind of go like that. Not perfect, but you see if we connect this now, this is B prime right here, right? You can see that this new figure should be basically the same shape, but kind of shrunk, about half the size, okay? And that's kind of how you do a dilation. And I'm sorry for the clumsiness of this app, but hopefully it kind of gives you the idea. All right. Next, scalar multiplication. This actually should not be too bad, I hope. So let's get going with this. See a different color. Okay, so scalar multiplication. All we need to do is we need to multiply. We have this 3 in front of this matrix, and we're going to multiply 3 by every number in the matrix, right? So let's go ahead and do that. What's 3 times 0 going to be? Well, that's going to be 0. What's 3 times 5? 15. 3 times 4? 12. 3 times 2? 6. 3 times negative 2? Negative 6. And 3 times negative 1? Negative 3. And if you were to like plot, these kind of points from this matrix, and the new one, it'd be 3 times as big. It'd be kind of like expanded from the origin, which is kind of cool. Okay, so that's that. Why don't you guys go ahead and do checkpoint 2. All right, same thing here. So we're multiplying 4 by every element in the matrix. So 4 times negative 6 is negative 24. 4 times 3, 12. 4 times 2, 8. 4 times 5, 20. 4 times negative 1, negative 4. 4 times 4, 16. And there we go. All right. Now, we got a lot more to go on here, so cool. All right, so example 4. We are graphing a quadrilateral, and we're going to dilate it. We're actually going to use a scale factor of 1/3. Is that a reduction or an enlargement? It's going to be a reduction, okay? So, yeah, let's actually make I think it's easiest to make a matrix here to kind of do this here, okay? So we have make some room here. So we have A, B, C, and D. We have this matrix, right? And we're going to multiply the scale factor of 1/3, okay? So the points for A was negative 3, 0, B was 0, 6, C was 3, 6, and D was 3, 3, okay? All right, if you want to try this on your own really quick, see if you can figure it out. All right, for A, so we're going to multiply 1/3 by everything in the thing here. So let's use green. So we have A prime, B prime, C prime, and D prime. Okay, so A prime, we're going to multiply 1/3 of negative 3 is negative 1. 1/3 of 0 is 0. See if you can figure out the other 3 if you needed me to go through that one. All right, 1/3 of 0 again is 0. 1/3 of 6 divided by 3 is 2. 3 divided by 3, or 1/3 of 3, is 1. 6 divided by 3 is 2. And 3 divided by 3 is 1. And 3 divided by 3 is 1. So let's graph these and see what's kind of happening here, okay? So we got negative 3, 0. Let's go ahead and do this. So we go left 3, put a point. That's A. B was 0, 6. Go up 6. That's B. C was right 3, up 6. That's C. D was right 3, up 3. So we have this kind of looks like a kite. We're going to use a dashed line to show that's where it was. This is the pre-image where we started. Okay, and now we're going to use green, and we're actually going to graph the new figure, and you're going to see what kind of happened here, okay? So negative 1, 0, left 1, 0, that's A prime. B is 0, 2, up 2, that's B prime. C is right 1, up 2, that's C prime. And D is right 1, up 1. That's D prime. And you can see it's basically like from the origin to every point is like 1/3 of the distance, right? So this is 1/3 of this entire distance, right? And so yeah, that's kind of how it works. It's pretty cool. So yeah, basically we took this shape and we reduced it to 1/3 of its original size. Okay. All right. Let's see here. Okay, why don't you try checkpoint 3, which is similar to more scalar multiplication. Go ahead and give it a try. All right, so we have, we're using R and S. We're multiplying by 2, scale factor of 2. So we have -4, 3, and we have -1, -2. And we're going to multiply that. And our new ones should have been, we have R prime, S prime. Okay, so 2 times -4 is -8. 2 times 3 is 6. 2 times -1 is -2. 2 times -4 is, 2 times -2 is -4. And there we go. All right, so we'll check my work here. Looks good. Cool. All right, and last thing we're going to be doing today is we're going to be doing a composition, okay? We're doing a composition, and we're actually going to use matrices for this, okay? So we're going to do a couple things. We're going to do, multiple things. So for the first one here, we're going to take a shape KLM, and we're going to translate it, x plus 4, y plus 2, and then we're going to dilate it with a scale factor of 2, okay? So let's go step by step here, all right? So our original figure, let's go with KLM, make an original matrix here. I think matrices are pretty nice for this, okay? Oops, a little bit bigger. All right, so what are the coordinates for KLM? Well, K was -3, 0. Oops. -3, 0. L was -2, 1. And M was -1, -1. Okay? If we're doing a translation, if we're doing a translation of x plus 4 and y plus 2, what are we going to do to this? Well, what we're going to do is we're going to do a translation matrix, right? So what are we going to add to the x's and the y's? Well, yeah, so if we're going to, x plus 4, we're going to add 4 to all the x's, right? Let me make this a little bit smaller. You're not going to be able to see this yet. So go like this. We're going to add a 4 to all the x's, and we're going to add 2 to all the y's. And that's going to give us our new matrix here, okay? So we have, let's see. Let's go like this. So, wrote kind of big here. That's okay. So, translation matrix. So let's, I guess we'll do this. We have K prime, L prime, M prime. Okay. Why don't you guys go ahead and see what this would be if we do our first composition here. All right, so we're adding 4 to all the tops. So -3 plus 4 is 1. -2 plus 4 is 2. And -1 plus 4 is 3. And we have 0 plus 2 on the bottom is going to be 2. 1 plus 2 is 3. And -1 plus 2 is 1. Okay? So that would be this first step here, the translation. Okay? Then we need to go ahead and we need to do a dilation with a scale factor of 2. So K equals 2. Is that going to be a enlargement or reduction? It's going to be an enlargement because we're multiplying by 2. We're basically taking it and making it 2 times as big. So let's go ahead and do this. We have K prime, L prime, M prime. And we are going to multiply by 2. Okay? So we had 1, 2, 3, and 2, 3, 1. Okay? And that's going to equal our new one, which is going to be K double prime, L double prime, M double prime. Okay? Why don't you guys see if you can figure out what this is going to be? So 2 times 1 is going to be 2. 2 times 2 is going to be 4. 2 times 3 is going to be 6. 2 times 2 is going to be 4. 2 times 3 is going to be 6. And 2 times 1 is going to be 2. Okay? All right, so let's graph all these now. Let's do the red first. So K, L, and M. -3, 0 is K. -2, +1 is L. And -1, -1 is M. Dashed line, that's where we started. Okay, so that's the original figure. Then we shifted it right 4 up 2, right, for blue. So we went right 1 up 2 for K prime. Then we went right 2 up 3, and that's L prime. And then we went right 3 up 1, and that is M prime. Dashed line still, that's another kind of intermediate image here. So we went right 4 and up 2, okay? And then the last thing we did is we dilated it, we enlarged it along using the origin, okay? So we go right 2 up 4, that's k double prime. We went right 4 up 6, and that's l double prime. And then we went right 6 up 2, and that's m double prime. And that, we took every length from the origin and we made it 2 times as big. Very cool. All right. Sounds good. Okay, checkpoint 4 is very similar. We have a 90 degree rotation, and we also have a dilation with a scale factor of 2. See if you can figure this out. All right, so we have C, D, and that was -2, 2, and 2, 2. Okay, so this is, yeah, it's the original figure. And then what we did is let's move this down here. So I'll write it down here. We have x and y, right? So a 90-degree rotation is opposite of, actually should be, let's see here. So we have C prime and D prime. It should be the opposite of y and x, okay? So opposite of y and x, right? So so y in this case for C would be 2, so opposite of 2 is -2, and x is -2 as well. Opposite of 2 is -2, and x is just 2, so we keep it like that. And the last thing we did is we did C double prime, okay? We're actually going to multiply, I'll do this again. So we'll do C prime, D prime. We're going to multiply this by 2, right? So we had -2, -2, -2, and 2. And that's going to give us our C double prime, D double prime, which is going to be, multiply those all by 2, we get -4, -4, and -4, +4. All right, and that's going to be our composition of functions, which is basically more than one, our composition of transformations, which is multiple transformations. And that's our end result. All right, that's all I have for you today. Thank you for watching. Have a great day, and we'll talk soon.